Hello again and welcome. Today I'm looking at an old oscilloscope. This particular plug-in is one that I had, and what ended up happening is one day I turned the scope on and it wouldn't power up. And of course, typically what I found with these scopes is the tantalum capacitors, like these up here, start to fail. So I've probably replaced, I don't know, probably 15 to 20 caps in this particular scope. So this is just one board of a plug-in. You can see it's all Ecologic. And what's happened here is we popped a couple of fuses. There's this one here and this one here, which are both 3 amps. These are the fuses that came out of it. And this is what we're going to be using to replace those. So a few of you have been asking me about running a new fluke meter. I have a non-contact volt/current clamp type meter, and there's a gentleman up on YouTube that had ran one and apparently wasn't very happy with it and was talking about how unsafe the meter was. I really have no idea. I've never seen one of those meters. The technology looks kind of interesting. I was hoping to find a patent for that exact meter, but so far I haven't turned one up. So a few people offered to go in together and buy me one of those, and of course I'm not set up for anything like that. Another person had written me and said that they would just buy the meter outright and ship it from Amazon to my house if I just send them my address. Yeah, there's really no need for that. Typically when I decide I'm going to run a meter, I just run it. So I've actually gone ahead and placed the order for that. I originally thought I'd buy the upgraded version of it, but I'm a little concerned if I do that and I'm unable to replicate their findings, that people would be concerned that I wasn't running the exact same meter. So I thought I'd be better off just buying the exact same one. The upgraded meter actually will go to a higher voltage. I've owned a few of these old LaCroix over the years. I've been pretty impressed with them for their age. I think they came out sometime in the 80s, I believe, maybe the 90s. The first ones I purchased actually have a VME chassis in them, and they're 68,000 based. The later ones were color, and those have a PC in them. There you go. 2 new fuses installed. Of course, we're going to need to figure out what the cause of that problem was. These 2 big ICs here, these are the A to D converters. It's actually 4 A to Ds per hybrid device. These pots on the sides here, these are what set the trim for each A to D, so you can get the offset voltage down. So when I was going through it, this is what I found was the actual problem. I believe it's just this capacitor here that's shorted. You can see I've removed this hybrid IC. Let's go ahead and pull that off of there. I'm assuming, yep, you can see that one's a short. Well, at least it's not shorted anymore. Just switch it to resistance. Let's see what we got. Oh yeah, looks fine. We'll go ahead and reinstall our little hybrid device. And let's go ahead and recheck that just to make sure. Yeah, it looks fine. So maybe we got lucky and it's just this one cap. Let me check that second one real quick. So I've been thinking about how to go about testing that clamp when it does arrive. If you guys have any ideas about that, feel free to chime in. Again, my concern with that meter is it looks like it's got a GDT in there, and I'm curious if you could get that to turn on essentially when it's in, I assume, the resistance mode. Would there be a low enough resistance with the PTC and the 1K resistor and essentially the GDT at 0 ohms to put enough current through a human to cause any problem? Now, somebody else had measured the back cover, and I think they were saying it was like a 2.2 nanofarad or something. I think it worked out to 1.2 meg at 60 hertz. So of course that resistance is pretty high, but the problem is the transients that I typically run through these meters are fairly fast. And so if you look at the impedance at say 100 kilohertz, I think it worked out to like maybe 800 ohms or something. It's quite a bit lower, and the problem with that, of course, is that's going to put a lot more current through whoever happens to be touching it. So I don't know if that's a problem or not. Again, I really don't have an idea what it would take to harm a human with these very fast transients. Again, if you're looking at like my static discharge test where I'm using that piezo grill starter, those are thousands of volts, but they're over in 5 nanoseconds. Of course, you can feel the bite off of those, but it's not going to kill you. With my transient generators, I put out quite a bit more energy than what that grill starter does, or my ESD gun. But again, the transients are over in about 500 microseconds. They pretty much settled all the way back down. Just looking at the block diagram for the 7242, and this is the card we're looking at here, this T7242 XTR. So it's the external trigger card. Give you an idea of what this looks like. See, it's just got this little clamshell that'll go around it. There's just 4 screws that hold this together. The reason I'd gone ahead and changed that second capacitor out is while the one was shorted, this other one is leaking pretty bad. See, like 517 ohms or so, while the other one is a dead short. So after replacing them, see, now we're in the mega ohms on each side, and this is just a plus or minus 15 volt supply going onto this trigger board. This cable goes off to the front board. This gets held into place with a piece of Kapton tape. I've seen LaCroix use various types of tape on these. Basically, the problem that they had is when you go to install the front control panel, it'll snag on this connector if it's not taped down, and it'll actually pull the connector off. So this whole assembly is built up onto this tray. You can see it's got some grooves in it. The circuit boards fit vertically inside of this. Just looking at the analog front end, this is all hybrid. There's 4 large ICs on this side of the board. These actually mount to the heat sinks for those. And there's 6 other hybrids in here that make up the attenuator. And then there's 2 other vertically mounted hybrids here and here. We have this control board. You can see it has multiple TMS 320s on it. This is a fairly later version of this circuit board. This assembly actually has the larger memory interface. I think these scopes were basically sold into the physics industry. They didn't have a good way to get the data out of the scopes, and so what they were using was a SCSI interface, and essentially they could stream the data onto a SCSI disk drive that was located in, for example, a PC, and that became essentially the network. Again, these cables are all marked, starting with P5 at the top, running down to P8 at the bottom. So we'll start off with the bottom. There's P8 and P7 and P6 and P5 and P2 is the top one and P1 is the bottom. These have to be tucked down this way. Again, there's a rotary switch that'll fit right here. These connectors go over to here. We start with E3. This is actually marked wrong. I know in this case E3 runs to the bottom. You can see this one is also marked E3. It probably won't show up on the camera from there, but I know that goes to E1 and this goes to E2. So that was a misprint. You can see right there, see there's two E3s. Just a mistake on their part. So we have two more screws that go into the bottom here. Hold that amplifier in place. Again, I'm not going to tighten these down until I get the cover in. These will have to be adjusted side to side to get the clearances right. We'll just snug them down, try to hold it in place. Next, there's this small back plate. Again, that's added for support. You can see it just bolts in right here. There's this plate with these notches cut that hold the circuit board spaced. Again, these scopes are fairly old. If you're going to work on them like what I've been doing, it's good to have a spare one that you'd want for parts probably. Again, with all the custom ICs and whatnot in here, you're just not going to buy these parts from DigiKey. Last piece we have to install is a backplane. You can see all the connectors here. That's what the backplane looks like. And this is a later revision of this circuit board. ECN 1003. This is a temperature sensor. Essentially, if this starts to overheat, this will break power to it. You can see it's right on the real heavy traces of the power inlet. And that just goes to the rear of the unit, like so. And then this just gets press fit into place. So to pull this off of here, what I use is two pieces of aluminum rod, and these just fit inside of these, like so. And I slide these in, one from each side. And then I can pry this up in sections, and that's how I remove this. As far as pushing this into place, it's just brute force. I just put a lot of weight into it, and this will set right down. Again, we want to kind of work this evenly. I'm sure at the factory they probably had a jig to do this. And there we have it. You can see this scope actually was property of the United States Air Force. You can see it still has the tags on it. Looks like its last calibration date was 10/23 of 98. So that's probably about the time it was decommissioned. And what had happened with this particular plug-in is I turned the scope on one day and it basically would not power up. And at first I thought it was the scope's power supply. And again, it turned out to be that one module. Things kind of have to be slid around a little bit for that to fit real good. I just want to see if it'll power up now, and if we can get a trace on it. Alright, cross our fingers, let's just see. I found the plug-in. Looks like it's initializing. Let's see. I'll just start with the first trace. This plug-in has the ability to output a pulse. Use that for TDR measurements. We'll just do set up the vertical, and we'll slide down here to enable the pulse. And here we can see the two waveforms. Let's just turn off the secondary digitizer. Got to run a calibration. Right, you can see we are currently at 500 picoseconds per division. It's running at 20 gigasamples per second. So this is channel A. Let's check channel B. First we'll have to move the probe down, and let's adjust our input attenuation. There we go. That looks fine. I think we got lucky again. It looks like just another cap was damaged is all. Alright, we probably want to check that trigger input. Let's make sure that works as well. Let's go to external trigger. Alright, go ahead and change our vertical setup. Let's change that second pulsar to on. Again, let's just go ahead and turn these off for now. So yeah, it looks like it's working. Again, let's just remove our external trigger. There you go. The last thing we have to do is install this cover. To do that, we remove the front. You can see this one, this traceable 1999, due March of 2000. This has the option L1, F2. This cover just kind of fits down over all this. when I first started playing with these old scopes, one of the very first things I did was I spec'd out all the hardware that it used, because a lot of the hardware had been stripped out. You know, people were tightening these things down with who knows what, but it actually stripped the ends of the screws. So I went out online, I bought a whole bunch of different hardware for pretty much every screw that these scopes use. And anytime I come across one that was partially stripped, I'd just get rid of it. These scopes just basically sit on my bench, so it's not like they get shipped around or anything. Again, we just snap this into place. And we install the 4 short screws. And just 4 covers that go over the top of these to protect them. There's one last thing we need to do, and that's tighten up these 4 screws now that hold the trigger and input assembly. So now, when you go to remove this, everything will be aligned. That's it for this repair. I know what you're thinking. There's extra screws that I forgot to put in. See, there's 4 of them. Those actually go to a different plug-in. See, I have another one sitting here. So this came from a friend of mine. He was going to pitch it. And I told him, don't you dare. I'll find a home for it, or I'll use it for spare parts. So, unfortunately, you can see what's happened. The knob was broken off. It was this way when he received it, way back when I was first working on these. I called up a company in Germany that made these, TT Electronics. Spoke with a person there and told them what I was doing as far as restoring some of these old scopes. And they were nice enough to send me some of the switches for these. You'll notice that there's 2 different types. And I have another front end here. This is one that I had saved for parts. Again, you can see the switch has been removed from this one. Somebody had probably pulled that off. That wasn't me. I also have a bag of knobs and then the front encoders here. So I think between all these parts here, we should be able to repair this. Right. You can see these are the white type switches. You can tell these apart. See, the other ones are black on the bottom. I'll probably just go ahead and put new switches on both of these while we're at it. Looks okay. Not sure if I have enough parts to put both these back together or not. Alright, just go ahead and tack this in. I'll tell you, this one is actually in much nicer condition. See, all the gasketing is still in place on this one. Looks like this one may have had a sticker or something on the front of it at one time. It's actually previous to the B model. All the ones I have now are B's. Case here is a little grungy. get some of that off of there. Yeah, it's cleaning up nice. Kind of want to get the buttons sort of aligned before you slide these together. Just get a couple of screws in there to kind of secure it. Yeah, they all seem fine. Looks like the board's sitting flat. Looks good. Alright, let's go ahead and tighten this one up. Yeah, they all seem fine. Alright, so now we need to install some knobs. Again, these are pretty dirty. I'll just go ahead and clean some of these up. We'll go ahead and snug these down a little bit. And now this stuff has to be real tight. That's probably how a lot of this gets broken. These are held on with a small nut. So you can just snug that down again. Nice. And we'll install our original knob over the top of that. Go ahead and install some knobs on this one as well. Alright, so I have all the screws installed. They're looking pretty good. Of course, then I realized when I went to put the knobs on the top that they don't fit. So that's basically the height that they have to be cut off. And the way we're going to do this is just to use a Dremel tool with a cutoff saw. Unfortunately, these are the last two large knobs that I have, and it looks like I don't have the end caps for them. Again, you just want a little bit of a gap there. Looks good. Go ahead and reinstall our screws. And I think we're ready to give this one a try. And with any luck, it should just work. So let's just check it out, see if it works. It's a little odd. We're seeing this one light up. Again, this is a pretty old plug-in. Oh, I did find it. So 7242. Oh, check seating to module A. it's definitely plugged in there all the way. You can see it's a little out of alignment. These are the 4 A to D's. And you can see how the pattern repeats. So there's 1, 2, 3, 4, 1, 2, 3, 4. So this could be aligned. You could get that in quite a bit tighter. We'll just let it warm up and see how it does. So let's go to display and vertical. And again, we'll go ahead and enable the 2 outputs. And let's just go ahead and turn these off again. Yeah, it looks like both channels, the A to D's, could be aligned. Alright, let's set it to ground. This would be 50 ohms. That looks fine. Again, this is AC coupled and DC coupled. Let's try the second channel. So AC coupled, DC, ground, and 50 ohms. Go ahead and set them both to 50. And let's check the time base. Let's check our offsets. So it looks like it basically works. Go to display and we'll change this to a dual grid. Again, this is 500 picoseconds per division right now. You can see there's a little bit of air between the 2 channels. Not much, just a little bit of offset it looks like. See our rise time here, it's roughly 500 picoseconds. So yeah, it looks pretty good. Again, when you consider the age of this scope, it's pretty capable what this thing can do.